Every morning, we wake to sunlight streaming through our windows, and it is easy to take for granted. The sun is constant, reliable, a silent companion in the sky. Yet this golden orb is far from tranquil. It is a raging, magnetic furnace, a boiling sphere of plasma, and its moods have a profound influence on the solar system. The sun is not just the source of light and warmth. It is the master of space weather, sculpting the environment through which planets, satellites, and astronauts travel. To understand space weather, we must first understand the sun itself. It is a massive ball of hydrogen and helium, powered by nuclear fusion at its core. Each second, it converts millions of tons of mass into energy, releasing it across the electromagnetic spectrum. From visible light to ultraviolet radiation, X-rays, and the solar wind, the sun constantly sends out a river of particles and radiation that interacts with everything in its path. This invisible influence shapes the conditions of near-Earth space, determining the safety of satellites, the reliability of power grids, and even the auroras dancing in our skies. The sun is not a perfect sphere of calm. It is dynamic and chaotic. Its surface roils with magnetic activity, producing sunspots, solar flares, and coronal mass ejections, violent eruptions that hurl billions of tons of charged particles into space at millions of miles per hour. These events are the engines of space weather, driving storms that can disturb Earth's magnetic field, damage satellites, disrupt communications, and even cause widespread power outages. The sun's influence stretches far beyond Earth, affecting planets, comets, and interplanetary spacecraft alike. Yet, space weather is not random. It follows cycles, patterns, and rhythms. Every 11 years, the sun goes through its solar cycle, shifting from periods of quiet to periods of intense activity. Sunspots multiply and migrate across its surface, flares grow more frequent, and coronal mass ejections become increasingly common. Scientists have learned to track these patterns, predicting the sun's moods and preparing for their terrestrial consequences. The solar wind is one of the sun's most persistent tools of influence. It is a continuous stream of charged particles, protons, and electrons that flow outward from the sun in all directions. The solar wind carries the sun's magnetic field into space, shaping the magnetospheres of planets, bending cosmic rays, and creating the invisible barrier that protects Earth from the harshest radiation of interstellar space. When the solar wind intensifies, it interacts with Earth's magnetic field, compressing it on the sun-facing side and stretching it into a long tail on the night side. This interaction can spark geomagnetic storms, which manifest in our skies as auroras, but can also wreak havoc on satellites, GPS systems, and power grids. Unlike terrestrial weather, space weather operates on a scale that is both vast and invisible. The storms are not of clouds and rain, but of energy and particles, traveling across millions of kilometers in mere hours or days. And yet, despite their remoteness, these storms touch our daily lives in subtle and profound ways. From the timing of satellite communications to the radiation exposure of astronauts in orbit. Solar flares are another dramatic expression of the sun's power. These intense bursts of radiation occur when magnetic energy built up in sunspots is suddenly released. A single flare can release the energy of billions of hydrogen bombs in minutes, sending X-rays and extreme ultraviolet radiation toward Earth. While our atmosphere shields us from the harmful radiation, flares can disturb the ionosphere, interfering with radio signals, navigation systems, and high-frequency communications. They remind us that the sun is not a benign neighbor. but a dynamic, sometimes unpredictable force whose activity reaches across millions of kilometers to touch our technology-dependent civilization. Coronal mass ejections, or CMEs, represent another level of solar fury. These colossal eruptions hurl billions of tons of plasma into space, carrying embedded magnetic fields that can interact violently with Earth's own magnetosphere. When a CME collides with Earth, it can produce geomagnetic storms of incredible intensity, the likes of which can induce currents in power lines, disrupt pipelines, and damage satellites. The Carrington event of 1859 is the most famous historical example. Telegraph systems failed, auroras glowed as far south as the Caribbean, and the Earth felt the raw energy of the sun unleashed in full force. If a similar event occurred today, the consequences for our technological society would be immense. And yet, not all solar activity is destructive. Space weather also produces some of Earth's most beautiful phenomena, the auroras. When charged particles from the solar wind are funneled toward the poles by Earth's magnetic field, they collide with atmospheric gases, producing shimmering curtains of green, red, and purple light. These displays are living reminders of the sun's invisible influence, a bridge between the cosmos and our daily lives. They are both a warning and a wonder, showing that the same forces that can disrupt technology can also inspire awe. Modern technology has made us acutely aware of the sun's influence. Satellites orbiting Earth, GPS systems guiding airplanes, communications networks spanning the globe, and power grids energizing cities, all are vulnerable to space weather. Engineers and scientists now monitor the sun continuously, using space-based observatories like the Solar Dynamics Observatory, the Parker Solar Probe, and the Solar and Heliospheric Observatory. These instruments track solar flares, CMEs, and solar wind conditions, providing early warnings that can mitigate the effects of solar storms. We have learned to prepare, to adapt, and to respond, because the sun will not pause for our convenience. The sun controls space weather not just through eruptions and storms, but through subtle, persistent forces that shape the very environment of the solar system. Its magnetic field, stretching outward for billions of kilometers, carries energy and charged particles that sculpt planetary magnetospheres, influence cosmic ray levels, and define the conditions of interplanetary space. Understanding this influence is not academic. It is essential for the safety of astronauts, the operation of satellites, and the protection of critical infrastructure on Earth. The sun is the ultimate conductor of the solar system's symphony, and space weather is the music it produces. From our vantage point on Earth, space weather may seem distant, abstract, and mysterious, but its effects are real, measurable, and sometimes profound. The sun is a force both nurturing and dangerous. It warms our planet and powers life itself, but it also hurls storms across millions of kilometers, reminding us of the vast, dynamic universe in which we live. The dance between the sun and Earth, the interaction of magnetic fields, particles, and radiation shapes the environment we inhabit, often in ways invisible, sometimes in ways spectacular. So the next time you see sunlight streaming through a window or witness the glow of the northern lights on a dark winter night, remember this: the sun is not passive. It is alive with energy, constantly shaping the space around it. It controls the weather of space itself, influencing our planet, our technology, and our lives. Space weather is real, and it is a reminder that our world exists not in isolation, but in a vast, energetic cosmos, governed by forces both visible and invisible.